Okay, good morning everybody. We're going to be starting today looking at chapter 12. We're skipping chapter 11. We're moving straight on to chapter 12, which, as you'll notice, is the last chapter in your textbook. It's not the last thing we're going to be doing. We will be adding something on the end. This is why we're skipping chapter 11. Anyway, let's get started. We're going to look at section 12.2, operations with radical expressions. And before we do that, it's worth reminding ourselves of radical expressions and how they can be simplified. Let's look at some specific examples. Let's say we've got a radical expression like that, square root of 32. So 32 does not have a integer root. It's not a perfect square. It does, however, have square factors. If you think about 32, 32 can be written as 1 times 32, 2 times 16, or 4 times 8. And if you look at those, you can see that actually that two of those are square numbers. 4 and 16 are both square, and they both give us a nice integer root when we find the square root. So what I'm going to do is I'm going to choose the larger of those two. We always choose the larger because it gives us the simplest expression. So 32 can be written as 16 times 2, which can be simplified to 4 root 2. Okay? So the 4 there comes from the square root of 16. And this is said to be a simpler form. Okay, let's look at how we can apply this when we do operations with radical expressions. And we're going to start off with the simple ones, addition and subtraction. So let's try square root of 2 plus 3 times the square root of 2. And in these examples, it's useful to think of the radical itself as a little bit like a variable. So, for example, if you have x plus 2x, you get 3x. In very much the same way here, root 2 plus 3 root 2 is 4 root 2. Let's look at a different example. Maybe a slightly more complex expression. 3 root 2 plus root 5 minus 4 root 2. Here we have different radicals within the expression, and rather like different variables within an expression, say an x and a y, or an x and an x squared, or something like that, they cannot be combined. So they will retain their own identity. However, there are two components here which do have common factors. So 3 root 2 and minus 4 root 2 obviously have a common factor of root 2. So they can be usefully combined. So 3 root 2 plus root 5 becomes 5 root 2 minus, becomes root 5 minus root 2. Okay? Let's try another one. They don't always look obvious with the same factor. So for example, let's try 4 root 3 minus root 27. This looks like two different radicals which cannot be combined. However, if we look at the second of these, 27 actually does have some square factors. If we write down the factors of 27, 1 times 27 and 3 times 9, we can see that the second of these has the square factor 9. So let's rewrite root 27 in that form. So that becomes 4 root 3 minus square root of 27 is 9 times 3. That can be simplified to 4 root 3 minus 3 root 3. That second component here, the 3 here, comes from the square root of 9 there. Now, 4 root 3 minus 3 root 3, we now have an expression with common factors within 2 of the elements. They can be combined, so this could be written as root 3 like that. Okay? All right, what we're going to do now is you're going to do some exercises. I'd like you to go to page 701 in your textbook, and we're going to be doing exercises 13 through 24. I'll include them here. Okay, there they are, in case you don't have your textbook with you, which would not surprise me in the slightest. Now, the way today's going to work is I think you should pause the recording in a few seconds, work through these exercises. Once you have completed them, check with the work solutions, which are pinned up on the rear wall. And once you're comfortable with this section and you feel confident that you can do this, move on to the next section, which is going to start in a few seconds. Okay, all right, so hopefully you've mastered that. Let's move on to a different operation, and we'll look at multiplication with radicals. Let's start off with some simple examples. If we multiply 2 radicals, what actually happens is we put them both within the radical. So the square root of 2 times square root of 8 equals the square root of 2 times 8. 2 times 8 is 16. And then we see that what we've actually created is a number with it's a perfect square. It's a number with an integer root. Square root of 16 is 4. Now all of this comes out of the rules that you saw a few weeks ago. You may well have forgotten them. Let's just write them down. So root A times root B equals the root of A times B. Let's look at a slightly more complex example. So root 2 times 5 minus root 3. All right, we're using here the distributive property, obviously. Root 2 times 5 is going to give us 5 root 2. Root 2 times root 3 is going to give us root 6. This expression cannot be simplified any further, so we're done. Great. So let's move on to the next section. Same page. So questions 25 through 33, which are here. Okay, again, work through these. Once you're comfortable with this section and you are getting the answers right, we'll move on. All right, okay, so let's look at what they call special products with radical expressions. So let's say we've got an expression like this, 2 plus root 3 squared. Now you may remember how this pattern works, or possibly the simplest thing to do is to write it out like this. And then we use the FOIL pattern. If you remember FOIL? FOIL first, so we'll do the first together. 2 times 2 is 4. Then the outside, 2 times root 3. Then the inside, also 2 times root 3. And then the last. root 3 times root 3. Let's simplify all of these. 4, well that's on its own. Two root 3 plus 2 root 3 plus 4 root 3, and then the final one, root 3 times root 3 plus 3. Square root of 3 times the square root of 3 is 3. This can actually now be simplified even further. Obviously, the integers will add together like that. And give us that expression. Okay, let's try another pattern. This is called the sum and difference pattern. 3 plus root 2 times 3 minus root 2. Now this pattern ought to be a bit more familiar, a bit easier to remember. If you recall that when we did this before, this would give us a squared minus b squared. The ab will cancel, there'll be a positive one and a negative one. So let's do that. So 3 plus root 2 times 3 minus root 2 gives us 3 squared plus minus root 2 squared. And that gives us 9. Root 2 squared is 2. 9 minus 2, which equals 7. Alright, the exercises for this section, 34 through 37. Okay. Okay. Right. Okay, we're going to end the new stuff today. Well, it's not really new. This is more of a reminder. We encountered this in the last time we met radicals, and that was the idea of rationalizing the denominator. Now, the basic idea here is it's quite difficult, or it used to be quite difficult, to do a calculation with a radical in the bottom part of a fraction, to divide by a radical. That used to cause serious problems for mathematicians with their mechanical calculation devices, and so methods were devised where you wouldn't have to do this. So the obvious method would be to turn that radical in the denominator position, to turn it somehow into an integer, and you would do that by multiplying it by itself. And the effect of this would be root 2 divided by root 2 times root 2, which is 2. So if you multiply by itself, you're squaring it, the radical is removed. And this is said to be the simpler form. The reasoning behind all this has now disappeared with our electronic calculation devices, and it's no longer difficult to do this. However, it is the practice has been retained within mathematics. It's sort of a bit of a holdover. But this explains why when you do these calculations, if you try 1 divided by root 2 in your calculator, many of them will give you this solution, root 2 over 2, and this is the explanation why. Let's look at some more examples. Okay, another one with a radical in the denominator position, so we multiply top and bottom by that same radical, and we get an expression 3 root 5 over 5. Okay, so the problems for this section are 4 41 through 46. They're on the next page. I think, yes, page 702. But once again, I will put them in. Okay, so only up to question 46. So let's get rid of some of those. So we're not doing these ones here. Okay, 41 through 46, just simplifying the radical expression. Okay, once you've completed these, again, checking with what's up on the wall, and what I'd like you to do is to move on to a couple of the word problems. And there are two there, questions 55. So there's questions 55 and 56. I'm going to go through these in a second. I'll go through the first and then I'll go through the second so that you can understand the thinking behind them all. But please try them for yourself first. Okay, right, so let's go through question 55. There is the question. Pole vaulter's approach velocity is related by the following equation. So they give us an equation with a radical in it. V equals 8 root h. You're a pole vaulter and you reach a height of 20 feet and your opponent reaches a height of 16 feet. Write an expression that shows how much faster. So this word here, faster, is implying the operation difference. So that's subtraction. So the difference, so your velocity would be 8 root 20 and your opponent's is 8 root 16. Okay. Now both of these can be simplified. We'll start with the root 20. So root 20 can be factorised as 1 times 20, 2 times 10, and 4 times 5. There's a square factor, 4 times 5. So 8 root 20 is 8 root 4 times 5. Root 4 is 2, so that's 16 root 5. 8 root 16, square root of 16 is 4. 8 times 4 is 32. So there is the simplified expression. 16 root 5 minus 32. If you then evaluate that in your calculator, you'll find that gives you a velocity of 3.78 feet per second faster than your opponent. Okay. Right, so let's do the final problem. Okay. There we go. Birds dropping clams, and there we have an expression with a radical in it. So t equals root d over 4. Height of 50 feet, height of 32 feet, and again we're looking difference. Okay. So let's do that. So the first one, the time would be root 50 over 4, and the second one is root 32 over 4. The reason we're doing subtraction is because of that word difference there. Okay. So this could be simplified quickly to root 50 minus root 32 over 4. 50 is simplifiable, so 50 has a square factor which is 25. So square root of 50 is the same as the square root of 25 times 2, which is 5 root 2. Let's try looking at what root 32 is. Root 32 is 16 times 2, so that's 4 root 2. So we can simplify the expression. So root 50 is 5 root 2 minus 4 root 2 all over 4, which gives us root 2 over 4. Okay? And if we evaluate that, we'll see that that gives us a time of 0.35 seconds. Okay, great. Right, we're done. The homework for today is going to be homework 12.2b, which is going to be distributed now. I think it's in a pile on the desk, and I will see you next lesson, hopefully with everything completed.